Hello viewers, today I am going to explain you a short notes about the shape functions in finite element analysis. So what is a shape function, we'll discuss in short. So before going to shape functions, we should understand that finite element analysis is all about dividing the complex object and into a smaller and simpler elements, and then we do the analysis. So first we take a complex object with a different shape, then we divide that object into different elements. As you can see here, we divided the element object into 3 elements, and then we perform the analysis on these independent elements. So we take each element, and then we do displacement. We find the displacement and stresses at the element level. At each element level we find the displacement and stresses. Then we combine all those independent element level displacements into a global displacement or a overall displacement. At the complete object level we find the global displacement. Then how to do that is by using two things. One is finite element equations. First step is to write the finite element equations, and then second step is to use the shape functions to get the intermediate displacements at the inside the nodes. So let's see how to do that. So first is, let us assume that there is an object element which has 4 nodes. So this element is again a part of the bigger object. So you take this object and we can see that we can assume that there are 4 nodes here. 1 and 2 nodes. 1 and 2 are the primary nodes, which are at the end of each side of this element. So 1 and 2 are primary nodes, and 3 and 4 are the intermediate nodes or internal nodes. We can call it as internal nodes or interior nodes. So we can our method will be first to find the displacement at the primary nodes, then to find the displacements at the interior nodes using those primary nodes displacement. So in order to do that, first we need to write the finite element equations, that is F1 is equal to K into U1 minus U2. Here F1 and F2 are basically the forces at node 1 and node 2. Forces at node 1 and node 2. So then we can write the equations like this. F1 is equal to K into U1 minus K into U2. Then F2 is equal to minus KU1 plus KU2. So here U1 and U2 are the displacements at the node 1 and 2, and F1 and F2 are the forces at node 1 and 2. So after writing down the finite element equations, we can solve these equations to get the displacements at node 1 and 2. Before that, first let's draw a diagram to represent the nodes on x and y axis. So you take this element, you can see that on the x axis we have x1, x2 and x3 and x4. So at each distance x, we can see that there are the displacements. So for example, at displacement x1, the displacement will be u1. At a distance x2, displacement will be u2. At distance x3, displacement will be u3. At distance x4, the displacement will be u4. So our goal is to find the displacement at all these points. So first to find the displacement at x1 and x2, we will solve these equations. So these algebraic equations we can solve, then we get the displacements at node 1 and 2, that is u1 and u2. Once we have the displacements at u1 and u2, I mean at x1 and x2, those displacements are u1 and u2. So once we have those, we can write the generic function like this. So the generic function is u of x is equal to n1 u1 plus n2 u2. So what it means is, if I want to find a displacement at any point x, then I can write a function called u at x. That means displacement at any point x is equal to n1 u1 plus n2 u2. So here we already know u1 and u2, those are the displacements at primary. So then what are these n1 and n2 in the function ux is equal to n1 u1 plus n2 u2? What are these n1 and n2? Those are nothing but the shape functions. Those are called shape functions. So here we can write that n1 is equal to x2 minus x by L and n2 is equal to x minus x2, x1 by L. So where x is equal to any distance, any arbitrary distance. Suppose if I say x is equal to x at 3 will be x3, x at 4 will be x4. So that way I can find out. So here I can say that before that what is L? L is equal to nothing but the distance between x primary nodes, that is x2 minus x1. L is equal to x2 minus x1. So in this, from these three statements, like n1 is equal to x2 minus x by L, n2 is equal to x minus x1 by L, and L is equal to x2 minus x1, we can at any given point x we can find the displacement. So assume that suppose at x is equal to x3, the displacement will be u is equal to u3, and x is equal to x4, displacement will be u4. So in this equation, if I substitute in this equation, if I substitute x3, then we can find out the value of n. N is equal to x2 minus x3 by L. So we substitute the n1 here and we substitute the n2 here. So we already know u1 and u2. So the complete sum of these two terms will give you the x3, I mean u3 at a distance x3. So that is how. Suppose if I substitute x4 here in place of x is equal to x4, then we find the n1 and n2 again, and then we substitute those values of n1 and n2, u1 and u2, we get the u4, that is x is equal to x4. At x is equal to x4 we find the u4, that is the displacement at point 4. So this way we can find the displacements at internal nodes x3 and 4. We find the displacements at 3 and 4, those are nothing but u3 and u4. So this way we can, using shape functions, we can find the displacement at internal nodes of any element. So that is the purpose of the shape functions. And these shape functions can be depends on the how is the element shape. That is why these are called shape functions. The element could be one dimensional or two dimensional or three dimensional. So depending upon the shape of the element, the shape function will also change. So that is the short description about the shape functions. Hope you understand this and like this. Thank you.